Physics of characteristic X-ray production. Now electrons incident on the target also produce characteristic X-rays. So an electron with kinetic energy E0 can interact with the atoms of the target. If it does, it can eject an orbital electron from the inner K, L or M shells. So we say that the atom has been ionized. अब कोई भी प्रोसेस को होने के लिए एक मिनिमम एनर्जी रिक्वायर्ड होती है, ओनली देन इट कैन हैपन. So the threshold energy that the incident electron must possess in order to first strip an electron from the atom is called the critical absorption energy. This energy is in keV range, kilo electron volts. Also, since the orbital electron is bound to the nucleus, so if at all it is to be ejected, the energy supplied by the incident electron must exceed the binding energy of the electron for that particular shell. कोई भी प्रोसेस को होने के लिए मिनिमम थ्रेशोल्ड एनर्जी चाहिए होती है. सो इफ द प्राइमरी इलेक्ट्रॉन विद एनर्जी E0 collides with an orbital electron in, let's say, kth shell, and it gives an amount of energy equal to delta E to that orbital electron, so the primary electron will recede or move away from such a collision with energy E0 minus delta E. For the orbital electron, a part of delta E will be spent in overcoming the binding energy for the kth shell, Ek. So that means that the rest of the energy, that is delta E minus Ek, will be carried away by the ejected electron in the form of its kinetic energy. Hence, a vacancy or a hole is created in the kth orbit. Therefore, an electron from a higher shell will fall down in order to fill that vacancy. So, as a result of this electronic transition, the energy is radiated in the form of electromagnetic radiation. So, for example, if the transition involved an electron descending from the Lth shell to the kth shell, then the energy of the emitted photon will be h nu, and it will be equal to the binding energies of the kth shell minus that of the Lth shell. Now listen to me very carefully. What happens is that, number one, if you use the target of higher atomic number such as tungsten, and number two, as these electronic transitions involve inner shells, that is, the electrons descend from higher levels to innermost shells such as K, L, M or N. If these two conditions are satisfied, then the characteristic radiations emitted are of high energies. How much high? Enough high so that they can be considered in the X-ray part of the electromagnetic spectrum. So this is the